So when my title and thumbnail claims that we are going to make Blender our bitch, I better deliver. And in this tutorial, you are in fact going to make Blender submit, and you're going to gain more dominance over your 3D software. I know you usually don't think of it in these terms, but we are going to make Blender our bitch in this tutorial, and really you're curious as to what this tutorial actually is instead of just packing it with swear words for comedic effect. Well, what this tutorial is it's actually about taking Blender and controlling it more so on a technical level, something that's like code, like Python code, but isn't quite there. And using what I'm going to teach you, it's going to be called drivers. We are going to control Blender in ways that you probably didn't know are possible. So before I get super into it, let me just give you a quick example so you know what's going on. So imagine that you have a cube, you want to move it on the x-axis. Instead of adding a location keyframe and then moving it, adding another keyframe such that this is animated, let's say instead I wanted to do this programmatically or kind of procedurally. Specifically, I want this to go down the x-axis over time. Well, to do this, you've probably seen me do this trick. On the x-axis, I'm going to write hashtag pound frame, hash frame, and when I hit enter, you see this becomes purple, which you might have not known is possible, but more importantly, you can see that this is moving down the x-axis, just with a little phrase. You didn't need to make any constraints, any geonodes, any keyframes, it just works. And additionally, if I go into here, we have the frame, it gets rid of the hash once you type it in. I can take this and multiply it by 0.2. In other words, I want to make it 5 times slower. And now we have an expression for that, okay? So there's a very simple example of a driver. And now that you've seen this, I can define what a driver is. In Blender, a driver is using some information to alter other information. So for example, in this example, in this example, I use the frame number, in other words, the time information, to modify the X information. So one is driving or controlling another. Now, more specifically, if we're looking at the frame number, what we're doing is we're actually looking at this property where it says frame 123 or whatever. So really, I'm accessing this data, I'm multiplying by 0.2, and I'm delivering it to the X component. And you better believe that we can get much more complicated than this. So let's just kind of keep leveling up. Let's say instead of this, let's do something that would be a bit harder to animate. Let's say we take the frame number and we compute the sine of it. So I'm taking the sine of the frame number. What do we expect to happen? And we can get rid of any keyframes we have. Well, it's just going to oscillate back and forth where I can divide the frame number by 3. So it goes 3 times slower. And now you can see we're getting complicated behavior that might have been hard to do even in the graph editor. And again, you can get as complicated as you want. If you can write it, then you can express it. If I subtract by 3, it's going to do the same thing, but it's going to be off here. So if I subtract by 10, for example, you can see it's doing the same thing, but over here, okay? You can get much more complicated with this, with maximums, minimums, arctans, but let's just kind of keep leveling up here. So we've determined that I can use one data type to change another. But what if I wanted to change it kind of like on user input, right? Right now, this is using the frame number, which we really don't have control over, except, for example, I can change the frame rate, and now it's going to do something like that. What if we wanted control? Specifically, let's say we have this light object, and as I bring this up and down, I want to move this one kind of left and right on the y-axis. Well, how do I do that without just typing hash frame? Because now we need actual information about the light. Well, to do this, very simple. You select your light. You're saying as I go up and down. In other words, as we change the Z component, you right click, you say, and we're going to get more advanced a bit later, but for now, you right click and you say copy driver. Copy is new driver, okay? Z component, copy is new driver, and then we want to move this cube based on that. So in the y-axis, all you have to do is paste driver. So now you can see this is purple. So not only is this oscillating because of our x sine function, but now you can see we're getting some nice control here. Now imagine that this light object, or really some kind of other object, was subject to gravity. Okay, so for example, we're running a rigid body simulation on an object. Well, we can then use that physics-based data to drive something else. So you could get quite complicated with this. Okay, and remember, you can modify anything here. So if I now go to this driver, so now we're going to get a bit more complicated again. This is the one dependent on the light. I'm going to right click. I'm going to go to edit driver. And now you can see we get this window here. I will explain this because we are going to get into this. Okay, so what you're seeing is that we have a driver. It's enabled. We're saying take the average value of, and this is where you kind of have to visualize this, is we're looking at the light object, we're taking its location, and this is what the driver is equal to. So again, for this cube, y-axis, I'm saying look at the light object. Specifically, look at location, and specifically this says location 2. What this means is it says look at the location on the z-axis. So just so you know, I believe 0 means x, 1 means y, z means 2. And you might be even able to do something like this. I'm not sure, so don't quote me on this. But here I wrote location.z. I'm going to update, and it still works. So there's other ways to write this. So what I'm trying to express to you is that in the driver, we can get much more complicated. So again, I'm saying look at the z component of the light, and then drive that over to the y coordinate of the cube. So everything's dependent on each other. Well, can we get more complicated than this? Yes. What if instead of the average value, which in this case means just take the number, what if instead I wanted to make a expression? Okay, so now we're going to get a bit more complicated. Well, at the moment, so I'm going to update. At the moment, nothing has changed. It still works exactly the same. But now we have an additional level of control, as you're going to see in a second. So we're looking at the light, we're looking at the z component, and this information we're calling location. Just to kind of get this a bit simpler, I'm just going to call it my data. Okay? Make sure you allow execution. Blender's saying, don't mess up your file. And I'm saying, I'm not going to. Okay? So in other words, I really don't like this window, by the way. It's not very, it always hides itself. Okay, so either way, I basically have a variable called myData. It can be called anything, and what it stores is the z location of the light. Well, at the moment, this isn't really going to affect anything because we're not using that variable. Well, now if I type in my data, you can see automatically it's updated because now we're taking the z component of the light and we're using this as an expression. Well, let's make this a bit more complicated. I can take the cosine. So now it's very similar to how we took kind of the hash frame thing. So now we have this x oscillation, again, because it's dependent on the frame number, but now the z doesn't only move the y, it does, but it's a cosine function, okay? Let's make something a bit more interesting. Let's have it be the cosine function times, I don't know if you can just type in frame in here, so this may or may not work, and if it doesn't work, we'll make it work. So I'm going to multiply by the frame number, and what I expect is now, yeah, it's going to move over time on the y-axis, so it's going to grow in magnitude. How do I want to do this? I'm going to do something different. I'm going to take my data and multiply it by the frame number. So I'm moving it inside the parentheses. The only thing that's changing here is now I'm saying I'm taking the cosine, but at a higher rate. So again, you can see it gets more chaotic over time because the cosine's moving faster and faster. Okay? Let's get a bit more complicated. because I think we are over this. So instead, I'm just going to write my data. So it's literally just taking the z component. And now, let's say we want this dependent on multiple variables. So this is something you cannot do with parenting. Let's say I also care about the z location of the camera. So now I'm going to, again, copy as a new driver, looking at the z location of the camera, go to the cube, go to edit driver. Again, this is just looking at the z location of the light. And can you guess what I'm going to do here? We're going to make it dependent on both. So I added a variable. So you can get rid of variables, you can add variables. I'm going to call this one my data camera. So now this is a completely different variable. And all I want to do now is I want to say, look at the camera's z position, just like the light. Well, in this case, we actually need to go into like Blender's data. So copy as driver didn't seem to actually be a good use case for this. Instead, we're saying, I want to make a variable, and that variable is going to look at, whoa, you can see everything is accessible here. Specifically, I care about, could we make it an object? We could. So I'm looking at the camera object, and we already know the expression for this. It's location .z. So in other words, we have one variable for the z component of the light, one for the z component of the camera. Right now, it actually will not care about the z component of the camera because we have defined a variable, but we haven't used it. We haven't used it. There we go. So if I make this relevant to my expression, I can add my data camera. Okay, so I have two variables, and both of their z contributions are going to add together. So what does this look like? It looks like this. The light controls it, and in addition, the camera controls it. So not the best use case, but you can see how you can get really, really complicated, where you can have multiple dependencies that act non-linearly, whatever, okay? I want to do something more interesting now. So one thing you might have noticed is in this driver, we had access, if we defined a variable and made it a single property, we had access to anything in Blender, and I mean anything. And my question is, how far can we take this? Okay, so let's see. I'm going to start off fresh with a cube, and remember how we did hash frame to drive the x component over time. Okay, so it takes this frame number and it maps it over here. Well, what if the hash frame didn't work? What if that wasn't a custom shortcut? How would we access this? Well, you could guess that, you might add a driver. Maybe we call this variable frame number. Again, in this case, it doesn't matter because there's a shortcut for this, but imagine that there wasn't. So I'm looking at the frame number, and I know I want to look at this property. Where do I get the frame number? Is it in the library? Is it in the mesh? Like, how do we know where it is? So now we're going to go a step above. What I want you to do, or to look on, is open a text editor. The text editor in Blender is just where you can write text. You can happen to write code in here, but it doesn't matter. It's just a text editor. The reason I opened this up is I want to show you what the data actually looks like for something like the time. So again, I want this to control our X component without using hash frame. Well, if I right click, I can have more options, right? Not just copy as a new driver, but copy data path and full data path. So I'm going to copy data path. So now it's in my clipboard. I control V, and you can see apparently this parameter is called frame current. I'm going to go a couple lines down. I'm going to do the same thing. Now looking at the first frame, as you might expect, this is called frame start. Okay, let's go even further. Let's look at the stereoscopy, which is to make like a 3D movie with those 3D glasses. I'm going to right click. I'm going to copy data path. And this has its own data path. Use a multi-view, apparently. So it turns out that everything in Blender actually has a data path. More specifically, if I right click and instead of copy data path, I copy full data path. So remember, data path gives us current frame current. If I copy full data path, it's going to be similar, but now you can see it's a bit more complicated. So we're looking at bpy.data, whatever. Let me tell you what this means because it's going to be important. BPY means Blender Python. You don't really need to care about it, but what it means is we're looking at Blender. In Blender's data, we're looking at the scene. That scene happens to be called scene, right? That corresponds to this one. I could call it anything, like test, which will make this not updated anymore. So if I right-click, copy full data path, and now you can see it's called test. And we're looking again at the current frame, but we're saying it's in the specific path, kind of like how you find a file in your, folders, right? You go to your desktop and then you go into your pictures folder. Same thing. We're going into Blender, we're going into its data, we're going into its scenes, specifically this one, and we're looking at the current frame. Now that's important because what if I had multiple scenes, right? These will have multiple different timelines. So these won't necessarily be the same. Okay, what's the point of this? The point of this is I'm saying you don't need to type in hash frame. In fact, you have this information right here. So let's try to use it. I'm going to go to Edit Driver. And in this fucking window, in this driver, I want to somehow get that data into here, okay? Well, now, if we go here, so again, just a reminder, we are driving the X component location of the cube using a custom variable. I called it frame number. And that variable should store what time it is, the frame number. Well, we don't know where it is in here, right? There's so much data. But now we do. So it's called bpy.data.scenes. Okay? So all of this is the data. So now we look at scenes, right? If it said point cloud, we'd look at point cloud. So we're going to go to scene, and then it's going to ask us which scene. In this case, we have two. Remember, we're looking at the test scene, the one that I called it. So this variable is going to be defined by the test scene, and specifically, I want to look at frame current. Make sure you spell this the same way. So now you can see, again, when I play this, it's all of the sudden moving. Okay? So my point is anything can drive anything as long as you know the data. In fact, let's try to get something a bit more complicated, right? So it's going to be roughly the same thing, but let's look at this stereoscopy. Again, I'm going to copy full data path. The reason for that is I want to know exactly where it is. A lot of your variables are actually going to be in the scene, but let's try to drive it based on this. So I would hope this works, but I am again going to move the X component, but this time I'm going to look at the test scene and I'm going to go to render.use multiview. So again, the way I know how to type this is I copied the data path and I'm just updating it, okay? So you can see this is updated to 0. Okay, that's kind of weird because the frame number gave us a number, so we know X location should be 1, 2, 3, whatever the frame number is, but this is a checkbox, right? Well, if I enable the checkbox and disable it, you can see all of the sudden, this is fun, all of the sudden it's moving. The reason for this is a checkbox, on or off, true or false, can be defined as 0 or 1. 0 means disabled, 1 means enabled. So of course, when I hit this checkbox, it's going to move 1 down the x-axis. Well, what if I wanted it to move down 10? I take the frame number and multiply it by 10. Again, not the most useful use case, but just to drive the point, to drive the point that you can literally change where a cube is depending on whether or not you're rendering in a certain way. Okay, so we should have just done the stereoscopy example where literally how you render seems to change where the cube is. So, that's interesting. I recorded something a bit after this that didn't really work. And that's because we need to level up, it turns out, our understanding of this, which I am totally open to. So how did I want to do that? What's our next example is basically what I'm saying. Well, what if instead of a simple checkbox, right? Let's say we literally take our render engine, whether it's Eevee, Workbench, or Cycles, and then we use this information to basically change a piece of text or something. So literally, it will display different things dependent on whether you're in Cycles or Eevee. So you can see how that's actually going to be a pretty interesting application. Well, I'm thinking just to start, let's do kind of a cool demo. I have a cube here, and I want it to basically output the text of what render engine we're in. So for example, if we're in Cycles, this cube should say Cycles. And then otherwise, I'm not going to subject myself to writing that again, Eevee or Workbench. So for this cube, I'm going to add GeoNodes. So we're not only doing drivers, we're doing GeoNodes here, whatever. Let's say that we want our cube to make, so let's use curves to strings, a piece of text. Well, string to curves, not curves to strings, basically lets us put in a piece of text. So I'm going to write input, and it's going to output that text. So unlike a text object, it's much more dynamic and easier to manipulate. So, and you have the benefit of GeoNodes. So when I put this in, we get the piece of text. Let me actually just fill it in so we can see a bit better, and it's a mesh. We can edit this to anything, okay? And what I want to do is I want to use this render engine as the text here. Now, this is why I had to cut, because it gets actually a bit complicated here. So let's say I want this piece of data. We know that we can right-click, we can copy full data path, we can paste it, and now we know that it's in our scene information. That's fine. By the way, I opened up a new project, which is why this is called scene instead of test. But again, I could call this anything, in which case I would have to update this. So I'm just going to, again, right-click, do that. So now it's called anything. Again, we know where this information is. It's in the scene called anything, and the piece of data, the label that describes this, is called render engine. Well, my point is that this piece of data is not like the others, where we're used to it kind of outputting kind of like a number, like its X location, on or off, or whatever. This, in some sense, should output a piece of text. So maybe it should say Eevee, or maybe it should say Cycles. And this isn't something that actually plays very nice with the drivers. So just to illustrate the point, if I go to scripting and I start changing our render engine, you're going to see on the bottom left, we get these expressions where the render engine is equal to different pieces of text. Okay? How do we get around this, right? Especially if I cannot right-click and change the string here, or I know what you're thinking, I can't change the string outside of here too. So again, the problem is I want this piece of text to say Cycles or Eevee or whatever, but we can't access the data of the string. Well, let's see if we can get around that. So I'm going to use a value, and this is something we can totally kind of edit with a driver. Basically anything anything that is a number is very easy to edit with drivers, but not strings and stuff like that. So let's say we have a driver. I'm going to call it engine to represent, again, allow execution. So I have the variable engine. If this will fucking stay open, I must be selecting it in kind of like a bad area. There we go. So I have a variable called engine that is going to ultimately express what render engine we're in. Well, first of all, let's try to get this data in, whether or not it works. So we have the engine variable. So let me define it. Again, we're going to call it engine and use a single property. And we now know where to access this. Again, we had the full data path, which I guess I deleted or something. Either way, we know that it was in scene. We know that it was in our current scene, and I believe it was render.engine, okay? So we have updated this but it's still outputting a number. In fact, it doesn't seem to be doing anything because it's still equal to 0. So this is the issue. How do we get string information? Well, it turns out Blender works a bit differently under the hood. In fact, if I change this render engine, you might notice that this number goes from 0 to 1 to 2. It's actually pretty similar to how we had location 0, 1, and 2. So we had that location array where I could write location.x, or instead I could write location 0. Indexing starts at 0, where if we have a list, the first item, EV is equal to 0, workbench is 1, cycles is 2, we can still capture this data in a way. So, for example, if I was to take this data and convert it into a string, so again, we don't have strings, so I'm going to try to use this 0, 1, or 2 to kind of get it to work. If I put this in right here, well, we kind of have something that represents it. It doesn't say EV, workbench, or cycles, but you can see the core mechanism works well. The idea is that everything in Blender ultimately should be able to be expressed as a number, and as long as we take this number and convert it using GeoNodes or something like that, we're going to be fine. But again, you're kind of constrained to the world of numbers often, and drivers do not play well with anything that isn't a number, as far as I know. Okay, so how do we take this and convert it? Well, actually very simply, I can add a switch node, which will let us pick between two options. Specifically, I want to pick between two strings, right? And let's say that the first one says EV, the second one says cycles, and I think 4.1 or something had an update where you could have as many sockets as you want in a node, but for now, that's not the case, so we'll use another node to say workbench. Or maybe, I think the order was the other way around. So we had EV, workbench, and then cycles. So let us do that. And you can see that if I put this in here, we do kind of have control over what this says, but of course, we need to control these values using our driver. So let's start very simply. I'm going to mute this node with this. So it's either going to be EV or workbench, depending on whether or not this is off. Well, we know that this should be enabled. It's equal to workbench when this is equal to 1, when we're on workbench. The first, again, EV is the 0th, when we're on the first thing on this list. So again, I'm going to take this. I'm going to say, is this equal to, we can actually use an integer here. So we can check, is this thing that again represents our render engine? So I know I'm kind of building this up here a lot, but we can actually just kind of rename this node. So this is our render engine. We check if this is equal to 1. In other words, is it workbench? And yeah, that should work. So we have EV, workbench. EV, workbench, but cycles isn't really included because we're either checking is it equal to 1 or not. We didn't account for the possibility that it could actually be equal to 2. So let's take this over here. I'm going to make this equal to 2. So again, when this is equal to 2, we are in cycles, which is controlled by this switch. So if I connect this right here, you got to think through it a little, but EV, workbench, cycles. So for example, one project, I work at this VFX company some of the time. One project that we've been working on is if we have a render, we want to know information about that render. For example, what was the frame rate of the render? What render engine did we use? So this is a way to get that data without having to type it in. It's automatic. In fact, we can get a bit fancier. So what I'm going to do is I'm going to join strings. So you can see how we're getting more and more complicated here. So I'm going to join strings so that I can put two pieces of information. I want this to say render engine equal to, let's put a space here. So notice that I'm putting a space here. It's not just empty, but there's a space. I want it to say the render engine is equal to whatever it is, right? So if I take this string and put it in the beginning, not the end would give us something like this, but we put it in the beginning, so this goes first, this goes second. Well, now we have a piece of data, a piece of text that we could do whatever we want with, ultimately. But you can see we have something like that. Additionally, we can extract data like the frames per second. Now, it turns out you can actually calculate the frame rate using a trick inside of Eevee. Inside of geometry nodes. But let's say we couldn't do that. So I'm going to take our FPS. Can you really not? Huh. So it turns out that some stuff you cannot pull. Okay, just as a side tip, just so people know, I know this has nothing to do with anything. If you take the scene time, and you divide one by the other. I need to think through it, which you divide by which. Might be the other way around. We take this and we convert it into a string. Let's see what this gives us. May or may not work. So 24 FPS, 60 FPS, and if you have like a decimal, it's going to round to 24, so make sure you have your decimals here. Just a little trick. You can calculate the frame rate. But let's say we had something that we didn't have access to, like the resolution. Then again, we can either do it as a driver. In this case, I'll do it, but you can copy as a data path. We have a driver. We paste that driver right here, and now we know our resolution is equal to 1920 for the x-axis. So I'm going to take this. Let's actually get both of these. So I want the y stuff, so copy as new driver, paste driver. By the way, you should notice, when I update this, of course, it dynamically updates, as you see in the purple. So just so you know. I'm going to join these together, which is just going to put them in like a long string where it should be cut right here. So for our delimiter basically means what should be in between. So I could put like a %sign, and now it's in between here. Of course, I want to put something like an x, so 1920 by 1080. Okay. This is going to be our resolution, so I'm going to make a similar string over here. So resolution is equal to. So now we have our resolution piece of text. We have our render engine piece of text. And of course, you probably see where I'm going with this. We can combine them to make a arbitrarily long thing. And by the way, you can see again, we have this issue where these are put back to back without a spacing. So for your delimiter, you can just put a space and hit enter. Or you know what? You could put a comma and a space to be more organized. So you can see now we have this dynamic thing that tells us. So I'm seeing that we have two x's here, so I want to get rid of that. It tells us the resolution. And additionally, it tells us what render engine we're working in. So that's just the use case we're doing at not my company, but the company I work in. So there you go. That's an application. So in this tutorial, thank God we have been recording. In this tutorial, we have indeed made Blender our bitch. And if you want to help the conquest of dominating Blender, whatever this narrative is, you've probably seen this entire tutorial. There's been a Patreon link, I think, here. It's not really a link. It's more so just promoting that it exists. There should be a link to Patreon in the description, where you can support what I do. But of course, you get stuff in exchange, like Blender files. So for example, I'm just going to save this as a maybe like Patreon driver info demo. You get access to any blend file I've made over the last couple years, some exclusive tutorials I made a while back, and sometimes early access. So I've made a lot of blend files that you can get for $5. Just download years worth of stuff. So I make that stuff available. Additionally, if you just see it as a donation, then I accept that too. So link in the description. And that's it. That's the show.